During the last week, scorching daytime temperatures baked 15 states across India, creating conditions that tested the literal boundaries of human survivability. This chart tracks the country's heat since 1901. March has now been recorded as the hottest in those 122 years, ending with a vertical climb into the red. In many regions, the thermometer stayed between 44 and 46 degrees Celsius for consecutive days, with some stations reaching the 47-degree mark. Historically, April averages 3 days of heat waves. This year, it registered 10. The frequency of these extremes has increased so sharply that the historical temperature profile of the region has been replaced by a much hotter, more persistent reality. But the weather in May did not continue this linear climb. Instead, the India Meteorological Department recorded a series of sudden, contradictory anomalies that brought widespread rain and a sharp drop in temperatures. Heavy rainfall swept across the country. In West Uttar Pradesh, some stations recorded 13 centimeters of rain in a single day, while other regions were battered by hailstorms that left streets covered in white ice. Massive dust storms also surged across the plains. In Delhi, the air became so thick with debris that landmarks like the India Gate were partially obscured, plunging the capital into a midday haze. We are seeing a shift where global warming does more than raise the temperature. It disrupts the timing of the seasons, creating a pattern where record-breaking heat is followed by violent, unseasonal storms. To understand this volatility, we have to look at the Western disturbance. These are storms originating in the Mediterranean that bring non-monsoonal rainfall to northwest India. Historically, they act as a safety valve, providing the moisture needed to suppress heat waves. But as the land heats up, these storms are changing. The increasing heat decreases their moisture content and forces them to travel at much higher elevations, causing them to pass over the plains and reach as far as the Karakoram range. When these cooling storms are absent, anticyclones, large-scale circulations of high-pressure air, settle over northwest India and Pakistan, rotating clockwise and throwing winds in every direction. This season, these anticyclones stayed in place for weeks. They drew hot northwesterly winds from arid regions and held them over the plains unchecked, acting as an atmospheric lid that trapped the heat over the subcontinent. The resulting heat waves are the result of this circulation failure. The cooling storms are physically displaced, and the high-pressure system remains stationary, keeping the region in a state of prolonged, dry heat. To find the source of this displacement, we have to look at the Arctic. Temperatures there are rising 3 times faster than the global average, causing a rapid loss of sea ice. This intense Arctic warming pushes air upward, creating low-pressure areas that pull subpolar weather systems away from their normal paths. This is what physically drags the western disturbances northward, away from the Indian plains. Simultaneously, anomalies in the ocean are adding to the chaos. This map shows cooler than average temperatures in the equatorial Pacific, a sign of ongoing La Niña conditions that alter trade winds and pressure patterns over the Indian subcontinent. The whiplash happens when these erratic ocean winds force moisture into the trapped, superheated air of the anticyclone. The high temperatures cause that moisture to rise and freeze rapidly, triggering explosive, out-of-season hailstorms. A sudden hailstorm in Delhi is a physical byproduct of melting Arctic ice and shifting Pacific currents clashing over the subcontinent. Forecasting models suggest that these atmospheric clashes are becoming a permanent fixture of the region's climate. These seasonal probability maps for 2026 show large areas of orange and red, indicating a high chance of below-normal rainfall. This deficit is projected to occur even as temperatures continue to rise. Long-term projections from the Ministry of Earth Sciences indicate that the frequency of summer heat waves will increase to 3 events per season by the end of the century, lasting up to 18 days each. Even with this rising heat, the risk of erratic thunderstorm and dust storm activity remains high. The moisture clashing with the extreme heat guarantees that the remaining months of the year will face these sudden disruptions. The historical predictability of India's seasons is giving way to a state of constant meteorological instability. As long as polar ice collapses and the oceans continue to warm, the resulting domino effect will continue to fracture weather patterns globally. Reducing future emissions remains critical, But mitigation alone is no longer enough to protect populations in the immediate term. There is an urgent need for adaptation across national infrastructure, agriculture, and public health systems. We must prepare for a future that includes both 47-degree droughts and sudden, violent storms. Surviving the coming decades requires a shift in focus, moving away from the past and building resilience for the era of